Hello everyone. Today we will be solving round 971F Firefly's queries where you are creating a new array. That array represents the concatenation of each cyclic shift of A, which means let's say that my A is 1, 2 and 3. Now I will shift 1 to the behind. This becomes 2, 3, 1. So 2, 3, 1 is appended behind. Now I shift 2 behind, this becomes 3, 1, 2. So 3, 2, 1 is appended behind. So this is the final array that the Firefly is making in this problem. What does it give us? It gives us two values L and R, and all we have to do is to find the sum between any bounds. Now the only issue is, since you are appending cyclic shifts, there will be n cyclic shifts. So if the value of array size is 10 raised to 5, that means the size of this entire concatenation will be 10 raised to 5 the whole square. Hence, you cannot store this array in any way. So you will have to use some maths to solve this problem. Now, how will we solve this problem? Now simple. If we want to find the sum of any subarray using prefix sum, how do we usually do it? What we do? We do answer of R minus answer of L minus 1. Which means in a prefix sum, we find the prefix sum up to rth index and we subtract it with the prefix sum behind the lth index. And that's how we always get the sum of any subarray, right? So in this problem, we will apply a similar technique to find the value of this sum. The only difference is we cannot store the prefix sum of any index because indexes will go till 10 raised to 16. Over here it n square, which is 10 raised to 10. Okay, so you cannot store the prefix sum. So you will have to use a different way. So if you want to find the sum between L and R, we will create a function. That function, let's call it find. Find of R will find what is the prefix sum up till rth index. Okay, and we have to find a way to find the value of find of R in O of 1 or O of log n complexity. Once we get the value, we can simply do find R minus find of L minus 1, and that would give our final answer. Now the main question arises how to create this find R. Now let's write some implementation of find of R. Now your array length is n. Let's say your n is equals to 5 and the index you are finding is 38, which means there have been 5 copies of the array which have been placed. No, wait, 38 is not a possible index. Let's take 17. Okay, if index is 17, that means there have been placed 3 cyclic shifts before 17 index, which means sum of my original array is present 3 times before this index. Hence, I have a part of my sum, which is sum of A into 3. Now, after that, I have found the sum of 15 indexes. Now all I want is the sum of remaining 2 indexes. Now I want to find the sum of remaining 2 indexes. The only issue is the remaining 2 might be in this format or it might be in this format. So it is not in ascending order of indexes because it is cyclically shifted. But we know that, let's say there is a cyclic shift. After the cyclic shift, your first element goes behind, and the remaining values are over here. After another cyclic shift, the second value also comes behind dot 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 a1 a2. So if you look at this, there it is not one increasing order of indexes, but it is two indexes. This one order is one increasing order, which you can query. And this one order is our increasing order number 2, out of which we can query. Okay, now I'll explain this further. Let's say you have a cyclic array, something like a of x plus 1, a of x plus 2, dot 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 dot, a of 1, a of 2, a of 3. Now you know that we will find the value, we will find the index of this value. Now let's say our array has been shifted 4 times. How will we get that? In the previous example, n was 5 and my index to find was 17. Hence, there were 3 cyclic shifts which happened before. So similarly, let's say that there have been performed 4 cyclic shifts. So what will be the value of a of x? Since I have performed 4 cyclic shifts, my behind array will look like a of 1, a of 2, a of 3, a of 4. And now my first index would be a of 5. So now I will find the remaining indexes, like how much indexes I will have to sum up over here. And first I will sum up using my this first increasing sequence, and then I will use my second increasing sequence. This will be more understandable with code. Okay. This is a class which I have made to give me easy prefix sums. Okay. Query L comma R, which means a prefix sum between L and R. Okay. This find function will calculate the prefix sum up to ind index. Okay. If index is 0, return 0. Okay. Now ind by a dot length is the number of cyclic shifts that have been performed up till that point. So my initial answer would be this into sum. Now ind upon a dot length. Ind divided by a dot length is the number of shifts performed. So I can get my number of shifts performed. And so my first index of the array is now shift, which I am storing in pointer. Now I will calculate how many numbers are present in my first cyclic shift, which means a of x plus 1, x plus 2, all the way till a of n minus 1. That is getting calculated over here. A dot length minus 1 minus pointer plus 1. This will give me the number of numbers in my first increasing sequence, which means a of x plus 1, x plus 2, x plus 3, all the way till a of n minus 1. This required gives me how many numbers should I use from my first increasing sequence. Like let's say if I require 2 elements, I would take prefix sum of this. If I require 3 elements, I will take prefix sum of this. 4 elements, I'll take this. Okay. So p dot query, I start from my pointer, end at my pointer plus required minus 1. Okay. Now I will reduce how many operations I have performed from my remaining. Now if I am done over here, which means now my second sequence is increasing, which means it starts from my 0th index and ends at whatever is my shift index. So whatever remaining queries are there, there would be 100% less than n only, the value of this rem. So I just take the prefix sum of 0 to rem minus 1. And this complete thing would give me the prefix sum of this cyclically constructed array up to ind index. And so now my question just boils down to find of R minus find of L minus 1. Okay, so this is it. Thank you guys for watching. Make sure to like, share and subscribe to never miss another tutorial.